All right, y'all. Today we're going to be talking about converting quadratic functions. Last time we talked about our three different forms of quadratic functions: standard form, vertex form, and factored form. And while each of those forms can be really useful to find various key features, sometimes we might have a function in one form that we need to then convert to another form. So we can actually convert between these different forms. There's lots of various ways we can do that. But the first one we're going to explore is probably the one that's not the most readily evident, and that's converting from standard form to vertex form. And we're going to kind of use what we know about each of these equations to actually create this conversion. So in standard form, we have y equals ax squared plus bx plus c. So we have a, b, and c. And what we want, if we're converting from standard form over to vertex form, is we need that a, h, and k. So we're trying to take our coefficients of a, b, and c in standard form and get them into those coefficients of a, h, and k over in vertex form. Now, the good news right off the bat, a in standard form is the exact same a that's in vertex form. And so we already have a from standard form. We can just take it straight over into vertex form. That second piece, x is equal to negative b over 2a, remember that is our equation for finding the axis of symmetry, and the x value of the axis of symmetry gives us our h value in vertex form. So the very last piece that we need, we have a, we have h, is we're going to need that k value. And if I have a, I have h, I can actually plug in and solve that equation, plugging in for x and plugging in for y, and actually solving for what that k value would be based on some of those values that I already have. Okay, so let's actually see it in practice. So we have example 1, y is equal to 8x squared minus 16x plus 27. So first thing we want to note right off the bat is that we do already have that a value, which is that value in front of our x squared. So a is equal to 8. All right, next is we want to go ahead and calculate that h value. So h is equal to negative b over 2a. So negative 16 is going to be positive 16. And then over 2 times our a value of 8. Then I just want to simplify from there. So 16 over 2 times 8 is 16 over 16. And 16 over 16 would be equal to 1. Okay, now that I have that h value, I'm going to take that h value and I'm going to plug it in for x in my standard equation, that one I have up there, y equals 8x squared minus 16x plus 27. Because if I have x, I can plug it in to solve for y, and that y value where the axis of symmetry occurs is that y value of the vertex, which is the same as our k value. So k is going to be equal to our y equation, but plugging in all the way across, so 8. And then instead of x, we're going to do 1 squared minus 16 times 1, and then plus 27. So you can see I took that h value right here, and I plugged it in to both of my x's, specifically in my standard form, not in my vertex form because I don't have everything for vertex form as of yet. So then from here, I can just simplify. So 8 times 1 squared is going to be equal to 8. 16 times 1 is going to be equal to negative 16. And then plus 27 is still just plus 27. Okay. And 8 plus 27 is 35. 35 minus 16 is going to give me positive 19. So now that I have my a value of 8, my h value of 1, and my k value of 19, I have everything I need to go ahead and plug into my vertex form. So y is equal to my a value, so 8, x minus my h value, so x minus 1 squared, and then plus our k value, so plus 19. And that's really all there is to it. It doesn't get much crazier than that. Of course, sometimes the math might get a little bit out of hand. But let's look at one more example. So example 2, we have y equals 5x squared minus 40x plus 67. So once again, my a value is 5. And then I'm solving for my h value. My h value is x, which is equal to negative b over 2a. So negative 40 would be 40. And then 2 times 5 for my a value. 2 times 5, of course, would be 10, so we get 40 over 10. And then 40 over 10 would be equal to 4. And I'm going to take that 4 and I'm plugging it back in for x in standard form. So y is equal to 5, parentheses 4 squared, minus 40 times 4, and then plus 67, which simplifying across, 4 squared is 16, 5 times 16 is 80, 4 times 40 is negative 160, and then of course I still have that plus 67. 80 plus 67 is 147, 147 minus 160 would give me negative 13. So once again, I have A, I have H, I have K, so I can plug that into my equation. 5x minus 4, parentheses squared, and then minus 13. All right, y'all, so that's really all there is to it. I want you to go ahead and pause the video and work on those 3 practice questions. See if you can do them without me. If you need to cheat, you can. But try and see if you can complete all of these and then unpause the video to see those solutions. All right, y'all, and just go ahead and check your solutions across. Pretty straightforward each time. We're identifying that A. We're plugging into our H equals negative B over 2A formula each time, simplifying that, and then plugging into our standard form to solve for K. And then once we have each of our 3 pieces, we're just plugging that in to our vertex form. Okay? All right, so let's pivot a little bit, and we're going to start converting from vertex form to standard form. So converting from vertex form to standard form is going to be just a little bit different because now we already have it in vertex form and we actually don't have to do any of those crazy solving steps, crazy plugging things in, plugging things out, because vertex is really just kind of a simplified version, almost like a factored version of standard form. So we can actually just FOIL that vertex form out and it's going to automatically give us that equation in standard form. But the big note that I want to make here, we have 5x plus 2 squared minus 9, is that x plus 2 squared does represent x plus 2 times x plus 2. So we would simplify that by FOILing. It does not represent x plus 2 like squared, so like x squared plus 4. We need to make sure we FOIL that all the way out so we actually get everything correctly multiplied and we get all of our extra terms. So we can go ahead and start by just rewriting this so it's easier to see that FOIL mechanism. So y is equal to 5 parentheses x plus 2, x plus 2, and of course I still have that minus 9 on the outside. So now that I rewrite it, you can actually multiply this in any order, 5 into the x plus 2, and then FOIL it out. I like to FOIL first, so I'm going to go ahead and do first times first, and outside times outside, then inside times inside, and last times last. So my 5 is still going to be on the outside. X times x is x squared. X times 2 is 2x. X times 2 is 2x. And then 2 times 2 is positive 4. And then, of course, I do still have that minus 9. Now, if I did my FOILing correctly, I should end up with those 2x terms on the inside that I can combine into a single term. So 2x and 2x do make 4x. So I can rewrite this as 5, parentheses, x squared, plus 4x, plus 4, and of course with that minus 9 on the outside. Now, after I FOIL it all out, if I have an a value that's larger than 1, then I'm still going to need to distribute that greatest common factor into my terms. So I'm going to take my 5 and I'm going to multiply it into each of my 3 terms on the inside of the parentheses. So 5 times x squared would be 5x squared. 5 times 4x would be 20x. 5 times 4 would be 20. And then, of course, I do still have that minus 9. And if I have a k value then, which you'll likely have a k value, but if I do, I should have one last combining like terms with that 20 and that minus 9, which would, of course, make 11. So our final equation, 5x squared plus 20x, and then plus 11. So all I had to do was multiply everything out. I didn't have to solve for anything crazy, do any extra steps, solve and plug back in. I'm just FOILing this out to convert it over into standard form. So let's do one more to practice together. So example 2, I have y is equal to -3, parentheses, x minus 4 squared plus 7. So first and foremost, I want to rewrite this as -3, x minus 4, x minus 4, and then plus my 7 at the end. Okay, then first times first, and outside times outside, and inside times inside, and last times last. So x times x is x squared. Of course, I do still have that -3 out front. X times -4 is -4x. X times -4 is -4x. And then -4 times -4 is +16, with, of course, that plus 7 still outside. Okay, then from there, I want to combine my like terms. -4x and -4x is going to make -8x, so -3x squared minus 8x plus 16. And then, of course, with my plus 7 on the outside. Then from there, I just want to distribute in that GCF, so that -3 is going to multiply in to all three of our terms. So we get -3x squared, positive 24x, and -48, which of course my plus 7 is still on the outside. If I did my job right, I got one last combining like terms. So my final equation, -3x squared plus 24x, and then minus 41. All right, y'all, and that's really all there is to it, to converting from vertex to standard form. Just like last time, I want you to go ahead and pause and complete the practice questions 1, 2, and 3 down there below. All right, so just checking your work really quickly. Once again, we want to rewrite each of these as those two binomials being multiplied, FOIL all the way through, and then of course distribute any GCF. You can see at number 1, we don't have a GCF, so it does make it a little bit shorter stepwise. 2 and 3, we do have that GCF, which then of course affects our final answer. And other than that, y'all, it's really just making sure you write as a binomial and that you do actually perform those FOIL steps and in the correct order. We don't want to be multiplying by that 3 or that -2 before we've split our binomial into the two separate binomials. Okay, now the last thing that we want to think about is, what about factored form? We didn't really talk about it. Well, factored form is relatively straightforward. We've already actually been converting to factored form. So if I wanted to go standard to factored, I could just factor. So y equals x squared plus 5x plus 6 would factor into y equals x plus 2 and x plus 3. And if I wanted to go factored to standard, just like I went vertex to standard by foiling, factored to standard would also be that foiling process. So if I had y equals 2, parentheses x plus 1 times x minus 4, I could just FOIL out my binomials and then distribute in any GCF. But of course, if it's in factored form, I won't have that extra k down there at the end. And if I want to move between vertex and factored, I'm going to have to use standard as kind of an intermediary. So either a vertex to standard and then standard to factored, or factored to standard and then standard to vertex. But that kind of puts a closer, y'all, on converting quadratic functions. Go ahead and complete those differentiated stations to practice all of these skills a little bit more.